Hello, thank you for joining me today for the Equals Math Lesson Component training. My name is Jenna Manuel, and I will be your trainer. Today, we will review the lesson components of an Equals Math lesson. If you have any additional questions, please contact the AbleNet customer service team email at customerservice@ablenetinc.com. Let's get started. When we pause to think about math instruction in the United States, historically, it has been primarily focused on teaching students a procedural knowledge while really neglecting on that conceptual knowledge of understanding. We have all been taught a procedure for completing a math problem, such as 60 divided by 4. Until very recently, we didn't spend too much time on teaching students that concept, however, in a meaningful way. Understanding the concept is essential when it comes to generalizing the skill and applying it to a variety of situations. It is for this reason that Equals focuses first on teaching students the concept. If a student can understand the why behind what they are doing, they can oftentimes use that skill in other areas. It also allows students to really think about what is happening and come up with ways to solve the problem that might not be the standard way. Teaching math in this way allows students the chance to experiment with concepts, test out their hypotheses, and make mistakes, all leading to a greater understanding of the concept and making math more naturally engaging and fun. Tricks and shortcuts should only be taught after a student has that firm understanding of the concept. Another philosophical point to embrace when teaching Equals is the progression of learning. This progression of learning refers to the sequence of learning concepts in a specific way to build knowledge over time. Lesson activities should be taught in the order in which they are presented so that students can benefit from this important support. Within Equals, the progression of learning can be found in two areas. One, within the lesson, as well as from lesson to lesson. Math is built upon a systematic progression of skills. Recognizing this connectivity within the math content area strengthens understanding of the concepts and skills being taught, as well as provides a foundation for students to be able to develop a deeper understanding. It is important to know about the connections within and between the content areas shown here. The lessons in Equals from all of these content areas are systematically arranged so that one set of skills and concepts supports the next set or subsequent set of skills and concepts. So here's an example from the math concept parts and whole. I know I'm going to find many examples of that within numbers and operations, but I picked this one. It is an equation representing the addition of parts 3 and 1, which results in the whole amount of 4. I can represent that idea with an equation, sets of objects. In algebra, I can use the concept of parts and whole to solve an unknown. It relies on that idea that I learned in numbers and operations, and now I'm applying it in algebra. Thinking about geometry when we talk about parts of a shape. I know parts of a shape are important in identifying like and unlike properties of shapes. I can also think of parts as sides, angles, number of sides, and that whole shapes created with those parts. In measurement, we think of a ruler as a 1 foot length. That's a whole. When we think of the inches as parts of the 1 foot ruler. I know in data, when I create a graph, I can take each part of information that I have gathered and I can put that together in a display so that I can make sense of and compare that data. The parts help me create the whole graph that I can now use as organized information. Recognizing and using these connections promotes generalization of concepts and reinforces the importance of the system of numbers and a connecting link throughout math. This built-in structure in and of itself is a support for students as it never changes. It is ordered and logical and is used and applied throughout all content. This is the reason it is so important for students to learn math in this way, building skills over time, and learning the system of numbers and its many, many applications to all content. The progression of lesson can most easily be seen within the contents pages of the overview manual. The objectives and equals have been narrowed for student success and are an example of one of the many ways students are supported within the curriculum. By narrowing these skills, we introduce these concepts in a more manageable format for students and focus on building knowledge over time. This progression of learning from lesson to lesson needs to be followed so that students have the knowledge of the concepts, tools, strategies, and vocabulary present in each lesson. This is building a solid foundation of math skills for the students. You can see in the example here on the screen how students are first demonstrating number sense skills using amounts to 5 and working with equal amounts, so that as they move on to section C, they begin to apply those skills by comparing amounts to 5 using words such as more, less, and equal, and then using those concepts to create graphs to compare. Each chapter will have multiple content areas covered to allow for students to experience that connective thread. Prior to teaching a lesson within equals, I recommend reviewing the chapter that you're going to be teaching to give yourself some time to view the connective threads within it. This will really give you an idea of the content areas taught and the direction that you and your students are going in. To sum up the philosophy as we move forward now, it is important to really think about and embrace this idea of that definite sequence of lessons. They have all been organized within a systematic format. This format allows students to develop and use a consistent math vocabulary and practice using math manipulatives in a variety of ways. The lessons are all organized within your 5 teachers' guides. Each book contains 2 chapters. Teachers should teach the objectives in the order in which they are introduced, and they should not skip around within the lessons or the chapters. Know that differentiation has been embedded into every lesson. There is a system of levels that support your students for the materials and the problem-solving activities. There's also a differentiation guide referred to as the Action Dictionary, which we will talk about during our training today. The order of lessons and the lesson components is essential for equals fidelity, so it should be embraced. As you begin to think about implementing the lessons, recognize that our equals lessons provide a rich view of math. Within each lesson, you will find the NCTM process areas present to support your instruction as well as student application of the concepts they are learning in a meaningful way. The 5 NCTM process areas present are communication, multiple representations, connections, problem solving, and reasoning improve. When we think about communication, communicating about math increases success. Learners can communicate their needs, wants, personal information, and knowledge in any way that is most meaningful to them. Within lessons, there are multiple opportunities for students to practice as well as teachers to model how to communicate about their math learning. Representations. Every lesson objective is shown using a concrete, semi-concrete, and abstract learning sequence. Extensive research shows that teaching math concepts utilizing this representational sequence increases student understanding and is beneficial for all classrooms. It is important to introduce all 3 representations to every student, as this really provides a comprehensive view of the math objective. Every lesson shows the concept using each representation. For connections, in the structure of a lesson, students activate and build background knowledge for the purpose of connecting it to their knowledge within and between all the content areas. That is how we all learn math. Equals lessons support students connecting their background knowledge to the math tools, actions, and strategies they are learning so they can practice and apply this learning to the activities that connect to the student's world. Problem solving. Problem solving is that culmination of communication, representation, and connections. When we think about how our students problem solve, asking them to pull together and come up with ideas is typically a very difficult task for our students. Good instruction will provide a way for students to solve a problem with the right amount of support that allows them to think as independently as possible. Differentiation will also certainly make this happen. The differentiation within equals includes leveled support, adaptation of student actions, demonstrations, visuals, hands-on materials, and choice of strategies. During our training, we will go through each of these supports. And finally, reasoning and proof. Reasoning and proof begins with identifying how a problem was solved or not solved, showing which tools were used, and how the strategy was applied is the proof of a correct solution. When a correct solution isn't reached, it is time for that discourse or that discussion to determine what happened and to think about, should we try something else? In this part of the lesson, that safe classroom environment is so important so that everyone knows it's okay to try and it's okay to learn from that mistake. When we really pause and think about how all of these process areas are related to teaching, it's within these process area that gives the students the opportunity to work together and communicate about the shared experience, which is the equals lesson. The teacher's role to support students within the lesson is crucial. The lesson structure allows for the teacher to foster a learning environment, which teachers are modeling the actions, the concepts, and strategies that are taught during the lesson. We all know that effective modeling and thinking aloud supports students' understanding and the development of the skills that they're learning. Teachers have the opportunity to communicate using the vocabulary and the action words in a meaningful discussion and with their small groups. The lessons allow for those hands-on engagement using the lesson materials and tools. And then students also have that opportunity to see how those tools are used or hear the language used appropriately before they themselves use it within that correct context with others. When you go to look at the lesson, really take comfort that all of those process areas and all of those opportunities that we just discussed on how to teach the lesson, they're embedded into each activity. When you look at each activity, know that those activities will provide you with directions on how to model, engage with the hands-on materials, communicate, and observe one another when working on that common lesson objective. This is an example of one complete lesson. Every lesson is 4 pages in length, and while the pacing of the lesson depends on the individual classroom experience, one lesson will take anywhere from 4 to 10 days to complete. The lesson pages are meant to be taught in order so that that progression of learning stays valid. It is important to know that the activities build and extend to the following page. Page 1 is a heavily modeled page by you as the teacher. The activities on this page ask students to activate the background knowledge and communicate about what they know about the lesson objective. There are also opportunities for you to model the math tools and action cards that will be used during the lesson. Page 2 then asks students to take what they know as well as their experiences from the first page and connect it to the lesson objective, but this time from a problem-solving lens. On the second page, students watch the teacher solve a problem, then get a small group opportunity to solve a problem together. Page 3 shows the lesson objective in a concrete, semi-concrete, and abstract representational sequence. It gives the students the opportunity to apply their understanding of the lesson objective by solving a problem independently. And finally, on page 4, this is our page of options. All activities on this page are there to extend what has been taught during the lesson. As we start thinking about teaching a lesson, I want to pause and talk about pacing. When you look at pacing for your lesson and about how many activities you plan on teaching per day for the lesson, it's important to keep in mind that you'll only be teaching about 1 to 2 activities per day. So when we think about how does that stretch out over the course of that 1 to 2 week pace, well, if you're following a little bit of a slower pace and you're only teaching about 1 to 2 activities per day, you'll get through the first page of the lesson by that Wednesday of the first week. You'll finish up the first week by completing page 2. And as you move on to week 2, you'll go on to your CSA, independent problem solving, and then end that second week with page 4. It's really important to understand that as you begin to teach equals math lessons, that you will only plan on teaching 1 to 2 activities per day. Do not attempt to teach an entire lesson in one day. It was not meant to be taught that way. Do make sure that as you get started, especially that first lesson you decide to teach, make sure that you're only trying to teach 1 to 2 activities per day. As your comfort with the curriculum increases, and if you feel like your students can handle an increased pace or more activities per day, you can certainly increase the pace. But when you're just getting started, start slow and just try to teach 1 activity per day. To get an idea of the pacing, here's an activity in action. This is one activity, and it's the vocabulary activity. Students are learning about the vocabulary word that relates to the lesson objective.
I got turtles. Oh, can you have the snake put the turtle in the bag for me? Oh, have the snake put him in the bag. Thank you. This is a set. Okay? I have a set of turtles. I have a set of turtles. What do I have? Good. What do I have? Oh, that was loud. What do I have? What do I have? You said it. Say it again. Set. What do we have? Evan, what do I have? I have a set of turtles. Are these the same? Yes or no? Are turtles the same as blocks? No, these are not the same. Turtles are the same. Blocks are the same. Turtles are not the same as blocks. These are categories. Category. I have 2 sets. Each of these sets is a category. Each of these sets category. This category is turtles. What are these? Category. These are each a category. This category is blocks, right? These 2 sets are separated by category. What is this category? Turtles. Evan, I have 2 sets. Sets, good job. Evan, they are separated category by category. What is in this bag? What is this category? Is this turtles or blocks? Evan, turtles or blocks? Evan, these are blocks. Blocks. Osvaldo. These are separated by category.
So this video itself was about 2.5 minutes, but the activity lasted 7 minutes. Now, some students may need to take a short break before moving on to the next activity, and some students may be able to transition smoothly into the next lesson activity. Again, it's really up to you and for your students to decide on whether or not you move on to that next activity. So some other important tips to consider when pacing your lessons are pacing guidelines will vary from classroom to classroom and even chapter to chapter. Attending to the lesson components we know develops over time. Oftentimes, those first few lessons will only last for a very short period of time. And this is something I experienced firsthand. And that should absolutely be expected as your student's stamina is developing. The first few lessons, the focus should really be on setting expectations for how to participate, interact, and communicate during math. Something else I experienced firsthand was to read the entire lesson once, all the way through prior to teaching that lesson. And then from that point forward, only focusing on the 1 to 2 activities that you plan on teaching for that day. And additionally, just pull those materials that you need for those 2 activities so that you're not cluttering your instructional space. You'll also want to make sure that you include review opportunities within your daily lesson plan. So that could be the first 5 to 10 minutes before the start of each lesson so that you can activate that prior knowledge, what was taught on the previous day, so that students can connect it to the learning that is happening in the next activity. So moving on to the lesson now, we'll focus first on the differentiation and the support that you'll find within that first page of the lesson. The lesson that we will be showing today is lesson 2B2, which is chapter 2, section B, lesson 2. The objective is student will construct sets of 5. We will go through each activity to get an idea of the philosophy of that activity. As we go through these activities, keep in mind those process areas that are embedded into each activity to support that best practice instruction. So as we move into page 1, it is important to know the differentiation and supports that are available. The supports available on page 1 are the action dictionary, the action cards, and the number notes poster. The Action Dictionary is found within the members only digital content within the resources folder and is the main differentiation guide for addressing individual needs. Prior to teaching a lesson, you do want to make sure you review this resource so you are familiar with it. The Action Dictionary provides differentiation for students during the lessons by providing suggested adaptations for actions that students are asked to perform. As you begin reviewing the equals lessons, you're going to notice that there are certain words in a purple font. These are considered student action words that students are meant to complete to be an active learner during your lesson. As you begin to read the lessons and find yourself wondering, how will my student complete these words during the activity? This is the time that you want to reference the Action Dictionary. So for example, if I'm looking at this page here on the right and I see in the game activity that my student is asked to count a set of cubes. Well, if I know my student will need support in knowing what the word count means and also that physical support of counting itself, I can open up to the page count in the Action Dictionary, take a look at the adaptations, and decide on the one that would support my student in completing that action in a meaningful way. In this case here, I might look at the idea of placing those connecting cubes, one on each finger, as a way to support my student who might need additional support when counting the connecting cubes with correspondence. During lessons, when we think about the action needed to engage with the materials out on the table, action cards are presented as a choice to support students in taking that first step with the materials out on the table. During lessons, both in the classroom and distance learning, be sure to act out as best you can the actions on each card with the materials you have out on the table. For classroom lessons, action cards are placed out on the table and are modeled using the equals kit materials. If you would like to use the Equals Technology Lesson Center to provide digital examples of the action cards, you can also have digital examples displayed on your smartboard or any other tablet or device that you might be using the Equals Technology Lesson Center within. Here's an example of how the action cards are called out within the lesson. Any activity with the 3 action words listed above within parentheses is an indicator to you to make sure you model the action words as they come up within the activity. All action card words can also be found within the action dictionary so that you can support your students when participating with these actions. Be sure to look through the listed supports in the action dictionary to decide which one will be the most useful to your students during the lesson. To get an idea of how the cards are used in action, I have an example of a teacher, Kara, working with a student. In this particular video, Justin is comparing a drawn set using the words one and many. In this video, Justin is using the action cards to communicate and decide on how he wants to engage with these materials. As you are watching, think about how the cards and the materials are used to support his actions, language, and independence during the activity.
All right, are we looking? Are we looking here? Are we looking here? Are we looking over here? Oh, you're gonna compare? Okay, how are we gonna compare these? Are you gonna compare by matching or labeling? By labeling? Okay. So then show me how you label. Oh.
What I love about this video is that Kara showed the action cards to provide the purpose and then reinforce the action within this activity. Justin had the opportunity to choose what action he wanted to take. And notice he selected his own. He wanted to label those sets. It's so exciting to see. And you can even hear him say, oh, label. This is important to know and to note here that this is year 2 of the curriculum. So Justin was the same boy who was in the first video with the snake. So notice how his behavior and even his demeanor with the materials themselves has developed. Over the first year, students begin to see how the curriculum materials are used to support their thinking and communication, and this video really captures that. Knowing that these action cards are there to really support students' communication, it is important to make sure that these action cards are consistently introduced and modeled by you this first year, so that as your students' comfort with the materials develop, they will start to see them as that communication support that they were intended to be. When you're just getting started with the action cards, this is another time for you to just kind of go slow and just make sure that first lesson that you're teaching, just make sure the action cards are out. As your familiarity with the activities develop, you'll find yourself referencing the action cards more and more and modeling them more consistently. But just in the very beginning, make sure they're out. And when you can, make sure you're referencing or modeling them as they come up naturally with the materials out on the table. The final support that we'll find on the first page is the number notes poster. So the number notes poster is introduced on the first page of the lesson to model how to communicate thinking and learning related to the lesson objective. What is most important to remember when completing the number notes is that communication should be thought of in the broadest sense. It is important to recognize all forms of communication when using the number notes poster. Be sure to incorporate those action dictionary adaptations as needed for students to support their engagement and communication. Closed sentences can absolutely be written on the number notes poster so that students can choose a pick symbol or object shown on the table that would complete the sentence. Math tools or environmental examples the students use are placed directly on the poster. Be sure to attach meaning to students' actions and with purposeful math language. If a student reaches for a particular math tool and demonstrates their understanding, add intent behind that action by saying, I see you placed one of the cubes on each finger to count. And you can represent that by placing those 5 cubes up on the number notes poster to add that meaning behind that student's action. Diving into the lesson basics now. On the first page at the top, you will find the lesson objective. There's a lesson number and a gray materials box listing the needed materials for the entire page. When you're looking at the gray materials box along the top, it is important to know that it is organized by parts of the lesson. On this lesson page, there are 2 parts, warm up and explore. When you go to teach the activities within the warm-up part of the lesson, you will use these materials listed on the warm-up side of the box. When you go to teach the 3 activities within the explore part of the page, you'll use the list of materials within the explore side of the box. Take comfort that the following pages are organized in the same way. As you view the amount of text, it is important to emphasize the text is not meant to be read aloud to the students. If you need to adjust the amount of language you say to your students to make it meaningful, go ahead and do so. Be sure to stay true to the vocabulary words and the essence of the questions asked, but do make those meaningful adaptations as needed for your students. As we dive into the philosophy of page 1 is all about building and activating background knowledge. In a nutshell, the philosophy of the activities are review vocabulary, model, observe, discuss the lesson objective, and introduce the tools and action words. As a reminder, you have the embedded differentiation within every activity here. So the action dictionary, your action cards, and your number notes poster. The first activity is vocabulary review. Vocabulary presented here has been previously taught. Questions are asked to probe and extend a student's knowledge about the word meaning. Concrete connections are always built during a vocabulary activity. Concrete connections are created together to provide a hands-on view. In this example, we are reviewing the vocabulary word 5. The purpose of the vocabulary activity is to show what the vocabulary word means using concrete objects. As shown here, wooden cubes are placed in a plastic bag to represent a set of 5. Once the set of 5 is created, the pick symbols, printed from members-only content of the vocabulary word, is placed on the bag to connect the vocabulary word to the concrete connection made. Once our vocabulary word is reviewed, the next lesson activity is the game. This game is one that has already been played in a previous lesson, but it supports the current lesson objective. To know the materials that are required for the game, read through the directions in the prep, and then the directions for the game are listed within the directions section. Math Dash is the next activity. Notice at the top of this activity, there are 3 action cards listed. This is a reminder to show and model the action cards as they come up naturally in the lesson. During Math Dash, teachers and students think and talk about the math concepts relating to the lesson objective, or it might also be an opportunity to introduce a strategy found within the lesson. This activity is important as it allows you to identify a baseline of what your students might know about the lesson objective. Take some time during this activity to model the action words, but also observe how your students are engaging when it comes to the tools and the actions. This can help you identify if there are any adaptations that you might need to use when it comes to your students using those tools or those action words. During the poster and cards activity, teachers promote a discussion about the theme and the lesson related concept. The theme poster in equals are intended to provide context for the objective. In this particular lesson, we are working with the ocean poster. To support students navigating the poster, the 6 poster cards matching that theme can be used. These cards were intended to support students who may have a difficult time identifying a single picture within the poster itself. They can also be used as a matching opportunity. So you can show that single card to a student to connect and discuss that image back to the lesson objective, then have that student match that card to the matching image on the poster. In addition to the ocean poster, the Equals Technology Lesson Center also has a wide variety of images that relate to each theme. You can certainly incorporate the Equals Technology Lesson Center during this activity as a way to really expand that conversation or that discussion, connecting back to the lesson objective. The next activity is the math tools activity. Now, this is an extremely important modeling and exploration opportunity for students to see how to use the math tools and manipulatives. On the next page of the lesson, students use the same tools to solve a problem. Make sure to provide enough time during this activity to model as indicated, but also to provide your students with time after your model to explore and engage the materials as well. So read through the activity to know the materials that you'll need and the types of questions that you'll ask that relate back to the lesson objective. As a reminder, the action cards are listed above the activity and they are there to support students' language and engagement with the materials. Be sure to model how those action cards are related to the tools. So in this example here, the teacher is showing how to count a set of 5 with circle counters and the tool a 5 frame. So I can reference to the action card count and say, I see this tool. It's a 5 frame. It helps me count a set of 5. I know that one circle will go in each box. And so I can model how I can count those set of 5 using the 5 frame. Then the activity is repeated with ocean counters and insect counters. So the teacher this time can take an opportunity to maybe model a new action word. So maybe instead of modeling the word count, I'm going to model the word place and show what it means to place a set or place those ocean counters on the 5 frame to make a set of 5. As I model making a set of 5, I'm referencing the action card and then showing that action. If this is a new action word or tool for my student, it is important that I first model how to complete these actions with these tools so that when they're asked what tool or what action do they want to take on the next page when problem solving, they have this experience to pull from. Once you as the teacher have modeled the tools in this activity, it is now time for your students to explore. So remember, this is that important opportunity for teachers and students to really get their hands on the materials. For teachers, it allows you to observe how your students are interacting with the materials and also how to support them as needed. As a reminder, if your students need differentiation when it comes to any of those action card choices, look to the action dictionary for examples of how to make those action words accessible. Those adaptations can absolutely be the strategies when students are working with the materials on the next page. For example, if placing cubes on the 5 frame is not appropriate for a student, but perhaps by placing 1 cube on each finger is more appropriate for them, that can absolutely be their way of solving the problem. Students need this time too to also become familiar with the tools and the language that they'll be using on the next page. So do be sure to provide ample time for students' exploration. And you might even find it helpful to include peer demonstrations during this time. Students are always excited to see what their peers are doing, and this is that great communication opportunity that's embedded right into the lesson. The last activity on this page is show and tell. The number notes poster is used to model how to communicate thinking and learning as it's related to the lesson objective. The structure of the lesson activity is broken up into 3 paragraphs. The first paragraph shows how to model an answer to the question, what do you know about the lesson objective? This is where you as the teacher will use the familiar experiences as well as the tools that have been used from all of the previous activities on this lesson page to show what you know about the lesson objective. This is then repeated with the second question. What do you know about the lesson objective? So students will use the materials out on the table to communicate their knowledge and answer the question. As students are engaging with the materials, be sure to place those materials up on the number notes poster to reinforce their communication and actions. The third question is, what do you want to know about the lesson objective? This is a little bit harder to answer for students, so you might need to model this quite a bit or scaffold as much as possible, but you might say, well, I want to know, what else can we count? Can we count 5 books? And maybe look at 5 books in our library that we can count. All of this is setting students up to really stop and think about the lesson objective and what they're learning, as well as the materials that they're using that can support them in demonstrating and communicating what they know. Here are some examples of completed number notes from the field. The picture on the left shows a combination of pick symbols and drawings to show what the students know about the lesson objective. The poster in the middle shows a combination of incorporating the manipulative pieces as well as short phrases. The third poster on the right shows the vocabulary words that have been taught throughout the lesson. It's important to understand that everyone's number notes poster will look absolutely different, and it should. It should all be reflective of how your students are communicating and are discussing what they know and want to know about the lesson objective. Page 2 begins with introducing new vocabulary and connecting the material shown on the first page to a problem-solving point of view. There are 3 activities on this page: vocabulary, think about it, and solve it together. The first activity is vocabulary. This activity introduces and teaches the new vocabulary word directly related to the lesson objective. The second activity is think about it. During this activity, the teacher models how to solve a problem using lesson materials and the problem-solving process. This important model is then used in the next activity, solve it together. This is a group problem-solving opportunity where students work with the familiar lesson materials to solve a problem collaboratively. In a nutshell, the activities on page 2 are built on developing a student's problem-solving skills. There are opportunities for you to model, discuss, and observe the problem-solving steps taught in every lesson. The important support that is used during the problem-solving process is the solve poster. When we think about using math from a functional point of view, problem solving becomes an important tool for students to utilize the concepts they are learning from that real world perspective. It is for that reason you will see equals lessons focusing on developing a student's problem solving skills. When we think about how we problem solve in our daily lives, when we are faced with a problem, we go through steps similar to the ones that you see on the solve poster. Now, it might not be in the exact order that you see on the solve poster, but for the most part, when we're faced with the problem, we begin by identifying the facts. What do we know? Then we think about the action we need to take. We think about what the solution might be. We estimate an amount or we predict what that solution might look like. Then we think about a tool or a strategy we might want to use. It's for that reason you will see multiple opportunities to support students going through these problem-solving steps in every lesson so that it too can become a more ingrained part of their lives. We all know that out in the real world, students are not always given that exact word or given the structure of a worksheet to work from to solve problems. It's the conceptual understanding of the concepts that they are taught, as well as that problem-solving process that makes math a more natural part of their lives. Asking students to use the skills they are learning from a problem-solving point of view allows students to move beyond just rote skill understanding, and give students that opportunity to increase functionality of those skills in their everyday life. The solve poster is used on the second page during the problem-solving activities. Think about it and solve it together. The solve poster displays the 5 problem-solving steps that are used to support students visually as they learn what it means to solve a problem. The 5 steps are facts. So what do I know about the problem? How can I identify facts? Action. What should I do? What action can I choose to solve this? Estimate and predict. Estimate an amount or predict the result or the solution. Tool or strategy. What tool or strategy can I use to solve this problem? And then finally, the solution. How did I solve the problem? It's important to remember that page 2 activities are about learning what it means to solve a problem by thinking through the solve poster steps. When you use the solve poster, think of them less as 5 steps to memorize and more as this is how the student can learn how to approach a problem. It is really a guide to help them think through that problem-solving process. For now, teach your students, but don't expect that they're going to know this process right away. As with learning the lesson objectives, learning how to solve and approach a problem takes time. This could ultimately take that full year, that full first year, for students to feel competent in this process. When using the solve poster, be sure to apply the same forms of communication when completing the number notes poster. So think about incorporating those concrete objects that are out on the table. Add drawings, pick symbols, all of that can be used to show what you are thinking as opposed to written sentences. So looking now at the structure of the problem-solving activities, it's important to know that these activities are numbered. Each numbered step of this activity is a step that you'll find on the solve poster. So if you find yourself wondering or a little apprehensive that first time that you begin to teach this activity about, okay, what will I write or show on the solve poster? Take comfort in knowing it's all there within the activities. The top line in the activity will help you identify the action cards that you'll want to make sure you have out on the table so that you can reference and model them. Remember, these are the same action cards that you had out and modeled on the first page, so they should feel familiar. The top paragraph will tell you the materials that you need to have out during the problem-solving activity. Again, these materials should feel relatively familiar as they have all been introduced and modeled on that first page. The italic font lists the problem. So as you read through the problem, begin to think about if you need to adapt any of the language to make it meaningful for your students. And then finally, the strategies are located within steps 4 and 6 within the think about it activity, and then together within step 4 for solve it together. Make sure you read through those strategies so that you have an idea of how you are using the action cards with the materials to show that strategy when solving a problem. Each problem-solving activity has a problem to read and solve. In the directions, it is stated to write and read the problem aloud to students. Now, this is an important step of the problem-solving process, and it is one that should not be skipped, but rather emphasized. The solve poster steps are anchored to this problem. Students need to see that connection between the solve poster step and the problem that they're asked to solve. So for this lesson, the problem is as written. Mrs. Lewis took her family to the beach. There were 5 family members. She needed to make sure that each person got a sandwich for lunch. How did Mrs. Lewis make the right amount of sandwiches? Now, for some students, I already know that this is far too much language. If you find that the language is too overwhelming or just distracting for your students, it would be appropriate to pare down the language to the problem's essence. Now, there are a variety of ways that this step can be differentiated to support a variety of learners. One of the ways that you can rewrite the problem and also pare down the language is using the Equals Technology Lesson Center. The text box tool can be used to rewrite the problem. The large image library can also be used to pick symbol support the problem. And then you can also incorporate the digital version of the solve poster on your workspace so that you can show your thinking as you go through each step. The images from the problem can then be placed directly on the digital solve poster to show the connection between the solve poster steps and the problem that was solved. You can also use a presentation software or a word processing program to rewrite the problem. These problems can also be paired with printed pick symbols from the members only content. If you're looking for the printed pick symbols, you will want to make sure you have requested the additional members only content and locate those problem solving pick symbols. You can search for specific problem solving units so that you can quickly print the ones that you need. Sentence strips and a pocket chart can also be used to rewrite the problem. Now, for students who are more concrete learners, look to the manipulative kit, content kit, and the materials from your classroom to help the problem come to life. Initially, students may need this concrete support to answer the questions on the solve poster, and adding these is a concrete way to show that the facts identified are from the problem itself. So when I ask my students to identify the facts from the problem, they might choose objects or cards right from the problem or from the display that I've created on the table. The support chosen by the student to answer that question can now be taken from the display or the problem itself and placed right up on the solve poster, connecting it to that step. This really fosters that connection between the problem that we're solving and the solve poster steps. Now, once the question is written and read aloud, it is now time to solve. So as a reminder, those numbered steps in the activity state the facts that you can identify to model how to think through a problem. Use the stated facts or adjust the language as needed to match your classroom. As you identify the facts, you can write directly up on the solve poster, or you can attach concrete objects or pick symbols to represent your thinking. Think About It was written to be a teacher modeled activity. So make sure to use the materials identified in the top paragraph to show your thinking as well as support student engagement. So for example, as I read the problem and identify the facts, I can use the yellow foam tiles to show the sandwiches that Mrs. Lewis needs to make. I can then place those tiles on the solve poster to represent what I know about the problem. The next step in our problem solving process is to identify the action we can take. So this is where you'll show your 3 action card choices, model each one if necessary with the materials on the table to provide that background knowledge for students. Then make your choice. You can say the script written right into the activity. I will count a set of sandwiches. You can then move that action card that matches the action that you're selecting right to the solve poster again to foster that connection between choosing the action and that solve poster step. Step 3 is to estimate or predict the solution. Now, the purpose of this step is to get students to stop and think about the problem they are solving. So often, math is all about that quick answer or that knee-jerk solution with little thought. This can really translate to little practice in developing a student's reasoning and proof skills, which is so important when we really stop and think about what makes math functional. This step in and of itself is incredibly abstract, especially if students have never been exposed to estimating or predicting a solution before. To support students in learning what it means to think about their solutions, provide choices of possible answers out on the table, and then post their choice to the solve poster to refer back to it once the solution is shown. This allows for that thoughtful discussion about whether or not that estimate or prediction was reasonable. Now, this, of course, will take time to develop, But be patient and know that providing choices of possible solutions is not about giving away an answer, but rather it's providing an opportunity for students to learn what it means to stop and think about what their solution may be. So in this example, I can show a set of a field of two. So I can show a set of 2 sandwiches and 5 sandwiches and say, all right, well, I know Mrs. Lewis needs to make 5 sandwiches. I estimate there will be a set of 5 sandwiches once I solve this problem. Now, once I have estimated the solution, I have to be sure to place my estimate on the solve poster so that it remains visible. Step 4 is identifying the tool and strategy you will use to solve the problem. During Think About It, you demonstrate one strategy at a time with tools. The strategy to demonstrate is listed in step 4. Use the script as a guide to know how to use the tools to demonstrate the strategy to solve a problem. As a reminder, if you need to cut down on the language present within step 4 to make it meaningful, go ahead and do so. The strategy that will be demonstrated is listed and underlined. So it's count a set of 5 from a pile of objects. To get an idea of what this looks like, here's the strategy in action.
For our first strategy, we're going to count a set of 5 from a pile of objects. The problem states Mrs. Lewis took her family to the beach. There were 5 family members. She needed to make sure that each person got a sandwich for lunch. How did Mrs. Lewis make the right amount of sandwiches? Let's count. 1, 2, 3, 4, 5. Mrs. Lewis could count a set of 5.
Once the strategy is shown, use pick symbols, written words, drawings, or even attached manipulatives to show your thinking. So here I can place the action card pick symbol count on the solve poster in step 4, and then place the foam tiles that I counted to represent the strategy I just used. The final step is to show the solution. This is done by showing how you use the tools and strategy to solve the problem. The solution is then represented on the solve poster. Use the actual manipulatives to show the solution, or use written words and/or pick symbols. An important step of Think About It is listed in step 6, which states to repeat steps 4 and 5 with the second strategy. Now, this oftentimes gets overlooked, but know that it is so important to make sure that you practice and model solving the problem with both tools and strategies, as students will be using and choosing which strategy they want to use in the next activity to solve a similar problem. So it's really crucial that you make sure that you show both strategies in Think About It so that students have that background knowledge to pull from in the next activity. So an example of how to repeat steps 4 and 5 with the second strategy is shown here. So I can repeat the second strategy, which is counting a set of 5 with a tool. So the math line or the 5 frame. So I can show my students what it might look like for me to think through this. Which tool do I want to use? Do I want to use the math line or the 5 frame? Once I decide on my tool, I'm going to then show how I would solve this problem using the 5 frame.
For our second strategy, we're going to count a set of 5 with a tool. 1, 2, 3, 4, 5. Mrs. Lewis could use a tool like this 5 frame to count.
The next activity on page 2 is a whole group activity called Solve It Together. This activity was written to give students an opportunity to work collaboratively and provide an opportunity to apply the language they have been learning all lesson to a problem. Now, initially, this activity may be heavily supported by you to be successfully completed as a group, and this should absolutely be expected. Make sure to provide ample time for your model as well as your students showing one another how they engage with the materials and the problem-solving steps. When you're viewing the solve poster, remember to represent on the Solve poster how students are completing each step with words, actual objects, as well as pick symbols. As a reminder, the Solve poster is less about memorizing each step, but it should be more focused on experiencing how to solve a problem using tools and language. As you move on to each step, reinforce that step by naming it and then showing how you, as an experienced math learner, completes that step with the materials out on the table. Then make sure to give each student that opportunity to show how they would complete that step, differentiating as needed. As you begin the problem-solving activities on page 2, think about teaching lessons with students who might require level 1 and level 2, and keep these considerations in mind. Make sure that you read the lesson objective and think about its essence. What is it that you want your students to learn? The objective is that driving force in the lesson. You are focusing on your students' understanding of the objective in the context of the lesson, and this does include problem solving. For students at a level 1 working on this particular objective, their focus may be on engaging with the manipulatives by moving the counters together to join. Know to always slow down the pace of your lesson. Your students absolutely need processing time to see and understand what you are saying and doing, and they need processing time to formulate and give a response. Make sure to pause frequently and repeat so that students can really absorb the essence of what you are saying. Be sure to provide support. The most basic way to do that is to provide objects that demonstrate the cause and effect of the math or the representations of identified vocabulary or math tools, objects, and actions. When you ask for a response, make sure to give 2 or 3 choices. For more details and ideas, you can always look to the Action Dictionary in your members only resources folder. For more information about how to effectively support students with significant to moderate disabilities, know that we have a pre-recorded training found on our Equals YouTube training channel titled Supporting Students with Moderate to Significant Disabilities. The philosophy of page 3 in a nutshell is to model, discuss, and observe the lesson objective through explicit instruction and problem solving. The first activity is that concrete, semi-concrete, and abstract representational sequence. This activity is direct instruction and modeling of the lesson objective using all 3 representations. During problem solving, students are showing what they know about the lesson objective and now apply it to a problem solving lens. And then finally, the lesson is closed out when students are asked to discuss and observe what has been learned during the lesson. Teachers will find a level system or a strategy to offer to students and their individual learning needs on page 3 of the lesson. The levels of support should be thought of as a fluid part of the lesson, utilizing any level of differentiation as it fits the student's needs. This differentiation approach supports all students learning alongside one another on that common lesson objective. When determining which level to choose for each student, read through the description to decide which support will best support your student's specific need. The first activity on page 3 is our CSA activity. This is one of the most important activities in the entire lesson. The teach activity shows the lesson objective in a concrete, semi-concrete, and abstract representational sequence. The materials that are needed and the directions for how to use those materials to demonstrate the lesson objective are written into the lesson next to each letter. When completing this activity with students, make sure to demonstrate the sequence twice for all students. Even for those students who you feel might not understand the abstract fully, or maybe for those students who might not need the concrete representation, it is still important to show each representation in sequential order so that students can really benefit from seeing that complete lesson objective using all 3 representations. An example of the concrete, semi-concrete, and abstract activity for this lesson is shown here with materials. So during concrete, actual objects, in this case, the ocean animals and the math line, are used to show how to count a set of 5. During semi-concrete, the 5 frame and the pick symbols of dolphins are used to demonstrate how to make a set of 5 using the 5 frame tool. During abstract, the teacher shows how to write the numeral 5 to represent a set of 5. After students have viewed this sequence, this is a great time to let students explore all of these tools to practice demonstrating each representation. After students have had an opportunity to view your model and then explore the materials, a skill worksheet is then completed. The worksheets are leveled to support each student's specific need. Select the level that best reflects each student's need. Worksheets were included in the curriculum to provide students with a paper pencil view of the lesson objective. However, it is important to still support these materials with the materials and manipulatives. So as you view the worksheets, consider the tools and the manipulatives you just demonstrated during the CSA portion of the lesson, and provide those materials to students to first demonstrate the concept shown on the worksheet, then provide that worksheet as an opportunity to record. So for example, here, if I wanted my student to identify the set of 5, maybe them looking at that semi-concrete representation of the sharks, the set of sharks and fish, is too abstract, or it's not one that they'll be able to engage with easily. So I can cut out those images of the shark on a separate worksheet, paste them on cubes, have my student make that set of 5 sharks, match those sharks to the worksheet, and then support them in recording their response on the worksheet. Remember, the worksheets are really just an opportunity to get your students practicing recording what they know. That demonstration piece is far more important than how your student is recording on a worksheet. The next activity is problem solving. Problem solving on the 3rd page is a culminating activity that allows students to apply the lesson objective concept when solving a problem. If needed, take time to review and discuss the action cards, the tools, even the solve poster steps with students prior to solving the problem. As with the problem solving activities on page 2, you'll begin by writing and reading the problem aloud to students. As a reminder, the problem is shown in italic font. If needed, rewrite the problem to adjust for language. Make sure to stay true to the math vocabulary and the essence of the lesson objective. The materials that are needed to complete this activity are listed in the top paragraph, along with the same 3 action cards that have been used throughout the lesson. So if needed, take time to model the tools with the action cards so that when students are asked, what action do they want to take, they have that background knowledge to pull from. The problem-solving activity has differentiation embedded into it. Notice the symbols L1, L2, and L3. These are representing the leveling system that is used to support students when working with the materials. Read through each levels of support and decide on the appropriate level for each student. Each level, the action cards and the materials are provided to support the student to solve the problem. For example, for level 1 support has the facts shown in the problem using manipulatives. So in this case, I have attached the pick symbols of the shells to cubes for accessibility for my student. I can then show the 3 action cards, count, move, and place. The student then chooses what action they want to use to solve the problem. So once the student chooses the action, I then choose the tool that they have been most successful with throughout the lesson, along with any additional adaptations. Now, when viewing the strategy options, it is important to note that there will always be 2 strategies to choose from. One strategy will always be a more concrete option to support students who need that level of support. For students at a level 1, it may be most helpful to choose the more concrete option to support their engagement and understanding. So for my student in this particular lesson, counting a set of 5 from a pile, and in this case, the cubes with the shell pick symbols attached to them, is much more accessible to them as opposed to placing those cubes in each spot on the 5 frame. Level 2 has students choosing not only the action they want to take, but also the strategy they would like to use to solve the problem. So in this level, I'll show my students both the action cards as well as the tools and strategies that have been introduced throughout the entire lesson. Level 3 has students choosing the action and strategy, but primarily level 3 is for those students who might just need coaching to solve the problem. Level 3 is really for those students who are working independently and they may make up their own strategy when solving the problem. At all levels, students are provided the problem-solving worksheet immediately to record their solution. So like skill worksheets, you'll choose the level that best supports each individual student's need. It is important to note that the problem-solving worksheets are labeled along the bottom as problem-solving worksheet, and they also have the level listed in the very bottom. When you're using the problem-solving worksheet, you do want to make sure that the problem-solving worksheet and the problem-solving component of the lesson stay together. So immediately after that student has demonstrated their solution with the manipulatives, provide that worksheet so that students get that opportunity to record their solution. As a reminder, you can always use the Action Dictionary to support students who may need adaptations when it comes to recording their work. So for some students, it may be absolutely necessary to have them first show what they know using the manipulatives, then you can support them with the recording. Using a paper and pencil should not be an obstacle for showing what a student knows. The demonstration and engagement with the manipulatives is far more informative for you as the teacher than circling or recording that correct answer. So in this example, if my student was able to sweep a set of 5 cubes with the shell pick symbols attached together to solve the problem, I could then support my student in placing those cubes on the worksheet to show how to record that solution by circling and isolating that set of 5. An important part of the problem-solving activity, as well as teaching math from that functional point of view, is communicating what has been learned. So the discuss part of this problem-solving activity is a part of the problem-solving activity, so students get the opportunity to practice showing one another how they solved this problem. All students may have used the same strategy, and that would absolutely be okay. But what is important is that students have the chance to practice communicating what they know, which is just further strengthening their reasoning and proof skills. Students can use the completed worksheet along with any materials to show how they solved the problem. This activity is a perfect time for students to also showcase a specific adaptation that they might have for an action word or a strategy maybe that they have created. The group problem solving challenge activity is next. This is an important part of Reasoning Improve as it allows students to stop and think about the facts that are relevant and irrelevant. If possible, keep the group problem challenge together with the problem solving activity so that students have that problem fresh in their mind. If it is not possible, do be sure to reread the problem and show again how the problem was solved to activate that background knowledge. During this activity, we discuss as a group what would happen to our solution if we changed relevant and irrelevant facts. So we can discuss, okay, what would happen if we changed the amount of shells that Opal needs to count to 4 shells? And then we'll solve and discuss. Does that change our answer? Well, yes, it does. 4 shells is less than 5. We can discuss an irrelevant fact. Well, what would happen if we change shells to fish? Does that change the amount at all? Does that change our solution? Nope, it just changes what we were counting. We're still counting a set of 5. Give students time to think about and explore these questions and then provide those materials to support their discussion. The lesson is closed out by completing the two activities, Math Dash Revisited and What Did We Learn? During Math Dash Revisited, you go back to the Math Dash activity from page 1, but this time students have all that they have learned throughout the lesson to pull from to explore and demonstrate what they now know about the lesson objective. During What Did We Learn? Students use the I Learned work mat and the student number notes page to show what they have learned. Taking a closer look at the I Learned work mats, these I Learned work mats are written to be a hands-on opportunity to answer the questions, what did you learn, and show it. Manipulatives, pick symbols, drawings, words, those can all be used to complete the work mats. Once students have completed the work mat, leave time for discussion and demonstration. The work mats are leveled, so do choose the level that best supports each student when completing the activity, and then make sure to provide each student with the materials from the lesson so that they can answer these questions. Another part of closing out the lesson is students recording what they have learned on their own number notes page. So these are smaller versions of the number notes poster that you completed on page 1. When you completed the number notes poster in the beginning of the lesson, you were modeling what it means to communicate about what is known. This is the student's opportunity to now practice communicating what they have learned. Show the completed number notes poster from the first page as your model and discuss. Then provide all the materials as needed from the lesson, including the action and vocabulary pick symbols to support students when writing about what they learned. Students working at a level 1 support may benefit from using the manipulatives to show what they have learned. Level 2 may use strictly pick symbols. Level 3 students may just write what has been learned. When viewing these pages, it is important to consider how your student is writing and what level of support and adaptations would make it most meaningful for each student to complete this activity. You may choose to create a math journal for each student to support this activity. These photos show math journals from the field. Notice the journal in the center has students using their number notes page as a way to record definitions of the vocabulary words they've learned during the lesson. The image on the left and right shows students demonstrating a strategy that they learned using pick symbols. What is important to notice here is that all types of writing are honored, from early writing skills to communication attempts. The fourth page is full of activities that allow you to extend and review what has been learned during a lesson. The activities on this page can be taught by paraprofessionals or support staff in your classroom to support small group rotations. There are 4 parts on this page: sensing math, real-life problem solving, partner problem solving, and games. The amount and activities you choose to complete on this page is up to you and your classroom need. There's not a material list for this page as the activities are optional. Any print materials for the activities are found within the members only content. To briefly go through each activity now, sensing math is the first activity on this page. This activity provides a practice and a connection to support a skill related to the lesson objective or an underlying concept using any of the 5 senses. In this example, students get a chance to make a set of 5 using a variety of materials. The first activity within real-life problem solving is a classroom connection. So this is an opportunity to show how the lesson objective can connect back to the classroom. In this example, we are taking the sets we made within Sensing Math and will display them in the classroom. The second activity is content connection. Content connection extends to cross-content topics that relate to the lesson objective or a skill taught. Common connection is the third and final activity within real-life problem solving. Common connections identify math found within the community, home, or common areas of the school, such as the hallway, lunchroom, media center, school grounds, or even a community trip to the store. You can also incorporate completing an internet search during this time as well. Partner problem solving is next. This is the final problem solving opportunity within the lesson. Students work in pairs to create their own problem based on the problem that was solved on the previous page in the lesson. This activity includes a page of pick symbols for students to choose from to create their own problem, and then they can provide that created problem to another partner pair to solve. Action dictionary adaptations, strategies, and materials are all used during this activity. The final two activities are the games. The concept game is one that reinforces the broader concept of the lesson objective. So in this example, students are working on matching sets up to 5. The skill game focuses on a particular skill from the lesson objective. In this example, students are using cut egg cartons as a fun alternative to the 5 frame to make sets of 5. In addition to the page 4 activities, there are a variety of opportunities to close out or review a lesson. The equals extension lessons, which are located within the members only content, can be used to review one or even multiple lesson objectives that have been taught. Reviewing the math dash activity from the first page of the lesson is a helpful way to review. Repeating any problem within the lesson as a group. And finally, completing lesson tests, which are also located on members only to assess student understanding. As you move forward with lessons, it is important to remember that a lesson should take anywhere from 1 to 2 weeks to complete. Mastery should not be the focus. If you feel that students need a review of a specific lesson objective, know that you can always come back to that specific lesson using any of the listed activities above, including even reteaching the lesson if necessary as a way to review. Home letters are available for every section in the curriculum, and they are located within the members only content. The advantage of home letters is that they are all-inclusive with home materials built into the activity or can easily be found at home. As we complete our webinar today, the next steps to take is first to make sure that you have established your starting section by placing your students in a chapter and section in the curriculum. Once you have that placement established, you can then start preparing for those lessons by section. Remember to use the materials list by section document to help you prep. Finally, after you have prepped your materials and established the expectations during your math time with your students, you can begin teaching the equals math lessons. Remember to give yourself and your students time. Yourself, you will need time to become familiar with the lessons, the materials, pacing, and differentiation. Your students will need time to become familiar with the materials themselves, the structure of the lesson, the language, the strategy. These all take time to grow and feel comfortable with. It should be expected to take a full year for everyone's comfort with the curriculum to develop. Equals is a rigorous curriculum. The benefits and growth you will witness this first year is by far one of the most exciting outcomes of using equals. Make sure to enjoy it. If you have any questions after our webinar today, please reach out to our AbleNet customer service team at customerservice@ablenetinc.com. If you are looking for additional equals resources, such as pre-recorded training, the Equals Technology Lesson Center link, standard alignments, the members only content that we discussed so much today, make sure to go to www.ablenetinc.com/curriculum/resources. Please reach out if you have any questions and enjoy teaching equals math. Thank you.